Question 10. Propanoic acid, methanoic acid, and ethane dioic acid. They are all weak acid. Draw the display formula for ethane dioic acid. Okay, so this one is easy. It's a dicarboxylic acid, or the simplest dicarboxylic acid. So you just draw this one. And the three acids, propanoic acid, methanoic acid, and ethane dioic acid, can be distinguished using a combination of two chemical tests. So cannot use acid-base indicator. Identify two suitable testing reagents and complete the table 10.1 to show the observation. Of course, the best two reagent is the Dolan's reagent and the acidified KMnO4. So we can use Dolan's or fillings because it can use to test this methanoic acid. Okay, why methanoic acid can react with the fillings and Dolan's? Because it has this aldehyde group. Even though methanoic acid has a COOH there, but it has another group, the aldehyde. So this one, it can react with the fillings and Dolan's. For the ethane dioic acid, this one, and propanoic acid, okay, they cannot react with these two reagents, the fillings and Dolan's. That's make the difference. And the acidified KMnO4, it can oxidize the ethane dioic acid and of course the methanoic acid. Both can. Propanoic acid, it cannot be oxidized by the KMnO4. So that's the ideas you must have before you suggest a reagent and give the observation. So for the propanoic acid, if we use the fillings Dolan's for the first reagent, so obviously it's no change, it will not react. And for the KMnO4, so also it will not really oxidize this propanoic acid, so it will be no change for both reagent. Methanoic acid will react with both. So if we use fillings, then it will be red precipitate. If we use Dolan's, it will be silver mirror. So only methanoic acid will have this positive observation, or is have this observation with the fillings and Dolan's. The rest don't have. And because methanoic acid, it can be oxidized by KMnO4, so the KMnO4 will change from purple to colorless, right? Because itself get reduced when it's oxidized the methanoic acid. The ethane dioic acid, it will not react with the Dolan's and the fillings because there is no aldehyde group there, and it can be oxidized by KMnO4, so it's from purple to colorless. The KMnO4, it will change from purple to colorless, positive 7 to positive 2. Okay, so by using these two reagents, then we know that the acid that no change for these two reagents, it must be propanoic acid. The acid that give a positive result or observation for these two reagents, it must be methanoic acid. The one that only oxidized by this KMnO4, but no change in these Dolan's or filling reagent, it must be ethane dioic acid. Okay, that's the observations that you must put. Okay, the last part. When propanoic acid is treated with chlorine gas in the presence of UV light, a mixture of products is formed. One of these products is 2,2-dichloropropanoic acid. Okay, explain why 2,2-dichloropropanoic acid is stronger than ordinary or the normal propanoic acid. Okay, refer to the structure of each compound in your answer. Okay, 2,2-dichloropropanoic acid is like this one. Okay, there are two chlorine atoms bonded to this carbon, which next to the COOH. First, you need to know the chlorine now is electrons withdrawing. So if you withdraw an electron to itself and it's two direction. So where is the electron from? The electrons, of course, is from this direction or this direction, right? So means some of the electrons it must form, for example, must form OH bond. So the OH bond, therefore, it will get weakened with the presence of the chlorine because it's withdrawn some electrons to itself. So that's the reason why the OH bond now is easier to break because it's get weakened and it can form more H+. More H+ means more acidic. And you can also say that because of these two chlorine, the chlorine is electron withdrawing, it can stabilize the anion. So means the positive charge here will be lesser with the presence of these two chlorine atom. So that's one you need to put in. Chlorine atoms is electron withdrawing, and it will weaken the OH bond, make it more acidic. Okay, that's all. Thank you.